Hello and welcome to the New Space Vision podcast sponsored by LiveEO, where we discuss new space technology, finance, and innovation with executives, founders, and more exciting people from the startup and new space ecosystem. I'm Sam Shivara.
And I'm Daniel Seidel, and together we are the founders of the Earth observation company LiveEO and New Space Vision. Today's guest is Sebastian Klaus, co-founder and CEO of Atmos Space Cargo, who are building capsules for research in space, as well as technology that enables safe re-entry from space. Welcome to the show, Sebastian.
Thanks for having me.
So, Sven, you actually, as an intro, have a special story to tell about the topic, correct?
Yep, that's correct. When researching, obviously, ahead of the podcast and obviously looking up what you guys are doing, and I've come across your company before, I remembered that I had a book in my bookshelf, which is a book from 1964. One of my hobbies, 1967, one of my hobbies is collecting old space books and book about the space industry. And I think the oldest one dates to 1920 or so. And they all speak about what the future might look like and what the future of the space industry might look like. And there was one particular book written by Werner von Braun. Within that, there were a couple of pages about how astronauts might come back from Earth in case the space capsule would have a defect or so. And there were a couple of examples being drawn by some of the big aerospace companies back then of how that might look like. And there was one example where an astronaut was sitting more or less out of a foam polster or something like that. With that, re-enter again and then land with a parachute. And there was another example of a deployable heat shield. And that was the reason, obviously, why that came back to my mind. And that really makes it extremely interesting for me today to talk to you, because what we're really seeing here is how science fiction becomes science fact, and you're doing that. So thanks also from my end that you found the time today. But before we dive into what your company does, you also have a very interesting background story, right at the intersection of space and defense. Could you quickly tell us what you've been doing before in a nutshell?
Yes, absolutely. It's actually interesting that you mentioned that story, because I think we've read the same old science fiction books. I think the project was called something like Moose or something like that, right? Like Man Out of Space Soonest or something like that.
Exactly. Something like that.
In front of me right now. Yeah, so I come from a very small place in Germany, middle of nowhere pretty much. And I've always been dreaming about the space industry already when I was a child and a teenager. And it's true, I come from the intersection between defense and space. And the reason for that is that I always wanted to find my way into the space industry somehow. And the way that I found was that I volunteered to become an officer in the German army. And when you do that in Germany, they pretty much pay for your studies. So I got my aerospace engineering degree at the University of the Federal Armed Forces in Munich, did my bachelor's about atmospheric reentry, who would have guessed it 15 years ago, and then did my master's at Airbus Defense and Space. Then I still had to fulfill a contract. So it was a 14-year contract total. So I served in Afghanistan and Africa. And in 2021, left the military and founded Atmos together with 3 co-founders.
And when you just said that 15 years ago in your master thesis, you already wrote the thesis about the re-entry, and then it took a while until you started the company for this. So was it always back then, also when you're servicing, was it always the dream to start that company, or did it happen later?
Always. It was always like in the back of my mind that when the contract would be over in 2021, I would start the company. But of course, to be honest, like 14 years in the military is a long, long time. And there were for sure moments like in Afghanistan where I was asking myself, like, Sebastian, what are you doing here, right? Like, it's very far away from your original dream now. But yeah, the dream was always there.
Yeah, but you also, your LinkedIn says that your service ended September 2021, and October 2021 states that you started to be the CEO of Klaus Space Transportation GmbH, which I think somehow turned into Atmos Space Cargo. So right, there's a direct transition.
Yeah, exactly. I went out and then literally 7 days later started the company and went all in. Like I took all of my savings from the military time and went all in. Yeah.
Well, that's dedication.
Well, what I also find interesting is, you mainly now think about returning stuff, bringing it down, but actually you also like to go up. So you're also a pilot.
Yeah, that's true.
How did that come?
I've always loved everything that flies. I think I got my first skydive in 2009, started paragliding 2011. I got my private pilot license in 2017 and then commercial pilot license in 2020. And so, yeah, if it flies, there's a high chance I can pilot it. I just love flying. I've actually been flying just a week ago in the Alps also. So it's one of my big passions. And I think it helps actually in engineering to not just have the theoretical understanding, but also like the practical experience of what is really important and what is like, nice to have.
And it's even a commercial pilot license, right? So airline transport license. So that sounds like a license which goes beyond just a hobby pilot.
Yeah, it's like in between, right? So there's like the private pilot license, and then there's the what you just mentioned, the airline transport pilot license, ATPL, and then there's an interim step in between, which is called the CPL, the commercial pilot license. So, and that's what I have. So you can use it to fly for commercial purposes, but you are not allowed to like move the Airbus with like 300 people inside of it. So it's somewhere in between.
So this dream of starting your own space company was there for more than a decade. And we have seen, besides servicing in Afghanistan, beside doing the pilot license, you also, even having a master degree, you went to the International Space University. And it's actually interesting. We realized, and we mentioned this in other podcasts, more than 10 guests we had here on the podcast were at the ISU, but I think you are the first one who already had an aerospace engineering degree. So what was your expectation? Why did you go to the ISU, and what did you learn there? What did it bring you?
Yeah, I mean, by the sheer numbers, right? Like 10 people on the show that were at ISU, you can guess how big that network really is, right? Probably some of the people also said it before. They call themselves the space mafia for a reason, right? Like there's like ISU alumni all over the world, in every space agency, in every major space company that is out there. And it just opens a lot of doors, right? Like you will always find an ISU alumnus who you can speak to get an intro to somebody. I was fortunate to take part in the ISU Space Studies program 2012. So that was the 25th anniversary of that project. And it was at the Kennedy Space Center in Florida. Pretty cool stuff. We saw 2 rocket launches. And, back then it was not like right now with SpaceX, where you see like a rocket launch every 2 days. It was like a rare thing that you saw an actual rocket launch. And we got to visit the NASA facilities, the vehicle assembly building. And, in my program, there were like, I think 130 participants or so. And so you create your own little network, and it just grows over time. So I can only highly recommend it to everybody who wants to build a network in the space industry. The ISU is really fantastic. And their main campus is actually in Strasbourg in France. And it happens to be that we also have an office there from Atmos, right? So if you want to visit us as well, just go to the ISU main campus, you'll find us.
Yeah. And we're going to get to that in a second, because we were also obviously seeing that you're a German-French company, more on that in a second. But so key takeaways from the ISU were definitely the networks. Are some of your co-founders also from the university, or where did you meet your co-founders?
Yeah, so actually my deputy, our COO, Marta, she also went to the International Space University, and we actually met at an ISU event in 2017. In Cork in Ireland, and also our head of business development, Guillaume, he's also an alumnus of the ISU. So yeah, it's quite the big network. For us, like the founder story goes like this. So I met Marta first, and I followed her career, of course, for quite some time. It was pretty impressive what she pulled off, right? Like she worked for NASA, she worked at ESA, both in the headquarters in strategy and also at ESTEC. She worked for CNES. She was launch safety engineer for Ariane 5, the largest European rocket in French Guyana. And, so when I left the military in 2021, I pretty much said to Marta, listen, like you're going to launch the James Webb Space Telescope on the Ariane 5. This is the climax of your career at Ariane Group, right? Like, Ariane 6, I mean, let's face it, it's a dead horse, right? Like it's not reusable. It's not competitive with the Falcon 9. So, that's the climax of your career. If you want to leave that company and start something new, here's the opportunity. You can become number 2 in this company. And luckily, she decided to go for it. And then Jeff, the third co-founder, got introduced to us by an investor, actually. So Christian Ziak from the High Tech Founders Fund said that, Sebastian, it's nice that you understand atmospheric reentry. It's also nice that you have leadership experience. But for what you want to pull off, like in-space manufacturing, for example, you need an absolute expert in building satellites. And I know somebody. So he introduced us to Jeff. And actually, Jeff and Marta had also met before. So, I mean, it's a small industry, right?
Yeah.
And then Jeff brought in our fourth co-founder, Chris, our lead systems engineer. So Chris had been working at the German Space Agency, DLR, for 12 years in the Department of Landing and Exploration Technologies. He was actually deputy head of the department in the end. So pretty much our public equivalent of what we're doing at Atmos.
Yeah.
And that's how all of...
And that's how the dream team assembled. Dream team to build what? So what is Atmos doing?
Yeah, it is indeed a dream team. I can say that quite proudly. I think for a European space company, it doesn't get much better than that in terms of founders. They're really amazing, and I'm really proud I can get to lead them. So what we do is we develop technology to return anything from space. We're called Atmos Space Cargo for a reason. So we focus on anything that is unmanned. Astronauts is not on our short or midterm agenda, but anything else we want to be able to return. And that means we look at, for example, biomedicine in space, like research and development, for example, for cancer research, for aging research in space, for 3D printing in space, 3D printing of human tissue. We look at in-space manufactured semiconductors. We look at in-space manufactured glass, fiber, or quantum materials. But we also look at all the other applications in the space industry that need return capability, starting with, for example, reusable spacecraft and launchers, right? So one of the biggest challenges that we have in Europe right now is that we don't have reusable spacecraft. I mean, America has the Falcon 9 with a reusable first stage. They have the Dragon that can come back from space. They will soon have upper stages that can return from space with the SpaceX Starship. We don't have anything like that in Europe. And it's a huge problem because that not being able to return means also we are not reusable. And not being reusable means we're not cost competitive. So we want to solve that problem. And obviously, it also has, let's say, defense and sovereignty applications, right? So you can think about actually storing security, military goods in space, in orbit, and then dropping it down on demand. So having that type of technology that can cover all of these use cases, that's our grand vision.
Yeah, holistic, horizontal technology. And the last use case you talked about, Daniel and I, in our preparation meeting to this call, also said, like, yeah, how cool that is. You stand somewhere in the desert, let's say, suddenly, and I don't know, it's not so cool to be stranded in the desert, but let's say you are, and then you get something, not airdropped, but space dropped.
Yeah, exactly. Like that pre-discussion, it seems like you could read the next question, right? That it's not only about returning, but actually deploying, right? I think when you look into the geopolitics, I mean, this is also completely science fiction, right? Could also be for emergency cases, right? If you are somewhere and you can just order, I mean, our thermodynamic professor always said, how much would you pay for water in the desert? And where does the water come from? Drones don't have the range, and it could be cheaper from space than sending a plane there at some point in time, right? Like, do you think about these?
Yeah, exactly. We're looking exactly at that. So that's let's say the dual use case, right? So if you were, for example, able to store high value medical goods in space, you could use that in a military, what we call mass scale scenario, right? Like you have an event of a mass of casualties that you just don't have the medical goods on the ground to treat all of them. So then you could just drop it from space into a military scenario. But you could also think of a more civil scenario where you have an earthquake, a plane crash, a forest fire, something that is like in a remote area of the world, and you need to have relief there fast. And fast means like within less than an hour. So if you have that, let's say, stored in space in, for example, several polar orbits in different planes, then you can really reach any place on Earth within less than 60 minutes. And that's, it sounds very sci-fi-ish, but actually from a technical point of view, it's within reach. And we're actually also not the first and also not the only ones in the world working on that capability.
Yeah. And did you already think about the unit economics? How much would that cost? Is that thought through already? Like, okay, I need,
absolutely. I think a few years ago, we would have said it's prohibitively expensive, right? Like you cannot really make that economically happen. But what's been happening over the last couple of years is, of course, that the cost of launch to space has gone down by pretty much an order of magnitude, right? A factor 10. And that brings those things into reach, right? So when we think, for example, about putting biomedical goods into space, the typical price tag that we aim for is around 45k euro per kilogram. And so that means that when you are a university, for example, and you want to put like a 2U sized micro laboratory into space, you can do that for less than 100k. That still sounds like a lot of money, but when you look at actually the amount of money that the military is, for example, spending on the rescue chain, right? Like when we were in Afghanistan, for example, there was something called the golden hour, right? Somebody would get wounded outside of a camp in, let's say, Mazar Sharif, and that person would be flown out on a helicopter within less than 60 minutes to a first treatment inside like still in country in Afghanistan. And then from there, you would have a dedicated Airbus to actually fly you from Afghanistan to Germany or to America to continue with the treatment. You can imagine what that costs, right? Like it's millions over millions. And so you have to put those glasses on pretty much, that this is for really high value applications. And when it comes to the other, let's say, more dark side of things, it's also for very strategic targets, right? Like you do not use, let's say, for example, drone support from space. You do not use that to support at, platoon or company level. This is like for high value targets, which are very, very deep behind the enemy lines. And then we are talking for sure single digit millions, in some cases double digit millions for such a mission. But in comparison to other systems that are used there, it's actually, don't want to.
Yeah. I definitely now have something new on the bucket list. I didn't add something to the bucket list for years, but in my life, I want to order with the mobile something from space.
Not that it's such a dark
not an emergency,
scenario.
not an emergency scenario.
Amazon Prime from space, huh?
Yeah, maybe exactly. So, do you mentioned now actually the applications in defense industries? Do you consider yourself being a defense company?
I would say we are clearly a dual use company, not an exclusive defense company. Actually, we started the company exclusively looking at the civil applications of space. But with everything that has happened over the last couple of years, right, like the Russian attack on Ukraine, the Trump administration being re-elected in the US and pretty much pushing for Europe to take care of its own business, JD Vance at the Munich Security Council, Zelensky in the White House, you name it, it became very apparent for us that Europe will have to do way more for its own defense, and that Atmos would also have to do its part. So I would say, like most space companies, we are dual use. We have a civil business, but we also have a military business line.
Yeah. And while the military business line and military customer can be counted on maybe two hands, which likely are front and center for you, who are the civil customers? You already mentioned a couple of use cases, but could you maybe tell us a little bit about like who a typical customer would look like? And if I read up correctly, you even had first customers on your first flight. Is this correct? Yeah. So maybe you could give us an example of what these customers look like and what future customers might be.
Yeah. Maybe I will start with how we actually designed Phoenix, the vehicle that we use now for these customers. So when we started designing the vehicle, we started by looking at the International Space Station, right? Like, because the ISS, it has been in space for 20 years now, and there are very clear utilization statistics that are publicly available also from NASA about what is actually going on the ISS. And one of the interesting things to learn there is that out of the 3,000 experiments conducted on the International Space Station over the last 20 years, more than 2,000 were in biomedicine. When you go even deeper, you also see that there's a lot of standardization already happening, as you can imagine, over like 2,000 experiments. There are standard form factors for these experiments that are used on the ISS. So, for example, something called the ISS mid-deck locker, and then also like the CubeSat form formats that are used for smaller experiments. And there are companies that actually specialize on these types of experiments and R&D projects on the International Space Station. Maybe to name a few, it's companies like Yuri in Germany, or Space Pharma, or Redwire, Frontier Space, Prometheus Life Technologies,
Space Tango,
IDK, Japan. What all of these companies have in common is that they have designed their payloads to be compatible with the ISS, meaning they need the atmosphere of the ISS, they need the right temperature, they need specific electrical interfaces and data interfaces. And our idea was, what if inside such a small automated capsule, like a robotic capsule, we could provide the same type of service that you find on the International Space Station.
Yeah.
Then probably we would be in a good position to find customers that would be willing to just switch from the ISS to our vehicle. And we were right with that hypothesis because, as you said, like on our first flight, for example, we had 4 different customers. 2 were from biomedicine, 1 from the UK, 1 from Japan, 1 was from semiconductor manufacturing, and 1 was from a space agency. So pretty much everything that you see flying on the ISS, we want to be able to fly also on Phoenix. And that gets much more interesting now because I think we've all seen that the NASA budget is being cut.
Yeah.
There are movements in the US calling for an earlier deorbit of the International Space Station. So the question is, where do all of those users of the ISS go next? Especially given that the commercial low Earth orbit destinations are mainly behind schedule.
Yeah, and this is, I think, a super smart approach because you already have a customer sample and investors will love you for that because you can say, hey, here are 2,000 examples of what customers could look like, right, with a customer portfolios. Just to so that I understood it correctly, what you're building with Phoenix and the family of Phoenix vehicles which you're building, right, from where you currently are to bigger versions in the future. What you're building is obviously the spacecraft, which would have room for experiments or whatever payloads customer would provide, plus the heat shield, correct?
Yeah, exactly. So it's all based on that same heat shield technology that you can scale up and down. And our first product, which we use to demonstrate that technology and also to generate our first revenue, is what we call Phoenix. And Phoenix is heat shield plus payload bay plus power generation plus data connections. So for the customer, it feels like an end-to-end service, right? Like they hand over the payload to us. We make sure that it's integrated, that it's launched to space, that it's operated in space, that we get the data for the customer down from space. And then eventually we also deorbit the vehicle, we recover it, and we hand the payload back over to the customer. So the customer doesn't have to have any, let's say, space background or experience, because that part is completely handled by us. The customer can really focus on what they are good at, for example, in biomedicine.
Okay, just so the customer needs to just comply to the standards which are already set, which are already out there, and give you the experiment in that format. Okay, super cool. Yeah, because we asked some of our listeners about some questions, and that was exactly one of the questions. What would be done by you? What would they need to take care of? Cool.
Yeah, and now to also for our listeners and also for myself. I mean, I've seen some images, but how does it look like? How big is it? Or what are the form factors of the Phoenix?
So when you look at Phoenix 2, for example, payload bay is the size of, let's say, a rainwater drum. Right? So 75 centimeters diameter, roughly 90 centimeters in length. So the volume is roughly 400 liters, and we can carry 100 kilogram of payload. So when you look at these big form factors that you find on the International Space Station, like the ISS mid-deck lockers, for example, they are typically like 30 to 35 kilograms. And when you look at the smaller ones, like the CubeSat-sized payloads, they are more on the order of like 1, 2, sometimes 5 or 10 kilograms. And so we can carry all of them, and we can also combine payloads, right? So we offer a rideshare service where, if somebody says, I have like a 40 or 50 kilogram payload, then that's our primary payload, which determines how long you stay in space and when you come back and specific extra services. And then we have secondary payloads that are then put on top, like smaller payloads. And that payload bay is then part of the larger Phoenix vehicle. And as you can imagine, with an inflatable heat shield, it's quite massive, right? Like as soon as it gets inflated, the Phoenix heat shield has almost 7 meters of diameter. So it's actually one of the largest blunt body objects to ever re-enter from space. Of course, Starship is bigger, but apart from that, I mean, in terms of diameter, it's bigger than a SpaceX Dragon, right? So it's quite massive.
But tell us a little bit about how you get a 7-meter diameter object into a Falcon cargo bay. Obviously, the world here is inflatable, but tell us a little bit about the technology behind it and how you came up with it.
Yeah. So the cool thing about inflatables is for launch, you can pack them quite small. And that's also the whole idea behind inflatables, right? So we are not the first ones to come up with that idea. The idea actually is like a mixture of some early Russian developments and then some NASA push that actually made it technically feasible and brought it up to TRL-9. So what NASA pretty much developed these inflatable heat shields for is Mars landing, right? Because as I think most listeners will know, the Mars rovers that are on the Mars surface right now, like 1 ton class roughly, they are at the upper limit of what's possible to put on Mars right now with current heat shield technology, right? Because you need a certain size of heat shield to bring 1 ton down to Mars. And that heat shield just barely fits into today's rockets. Right. So if you want to bring something heavier than 1 ton down to the surface of Mars, the heat shield would have to be even larger than that. And then it doesn't fit into the rocket anymore. So what's the solution? Well, you fold the heat shield. That was the whole thinking on the side of NASA. And that's why they came up with something called the HIAT, the Hypersonic Inflatable Atmospheric Decelerator, that flew successfully 10 years ago. And then just 2.5 years ago, NASA had another successful test program called LOFTID, the Low Earth Orbit Flight Test of an Inflatable Decelerator. And what they did is they put 1.5 metric tons into low Earth orbit and then deorbited it and successfully brought that through the atmosphere with an inflatable heat shield, which was super nice for us because at that point, our company was just 1 year old and NASA had just taken a technology risk out for us. So we were like, thank you, NASA. That's pretty amazing. When it comes to the actual details, there are some major differences between what NASA does and what we do, specifically in the inflation system. So NASA, for example, carries all of the gas needed for inflation up to space with the vehicle. So they use exclusively nitrogen from gas bottles to inflate rubber tires. These rubber tires are then reinforced with Kevlar to form like a proper structure. And then because rubber and Kevlar, they cannot go to very high temperatures of reentry, they have several layers of insulation. And then on the outside of the insulation, they have what's called a flexible TPS, a thermal protection system made from ceramic fabric. So we said, looks pretty good already. Maybe we can still improve that by reducing the amount of layers, right? Like the amount of insulation that is really needed. And also by reducing the amount of gas that we have to carry with us. And we came up with the idea that, first of all, you could use what we call a hot structure. So instead of having like, rubber tires and Kevlars to carry the load, we actually have ceramic fabric that actually carries the load, which means our whole structure can get to those hot reentry temperatures. And number two is we use what we call an air breathing system. So as soon as we are inside the atmosphere, we use little electrically powered turbines to suck air from the atmosphere inside of the heat shield to keep it
science
inflated.
fiction shit.
Yeah, it is quite sci-fi-ish, yeah, for sure. And the interesting thing is, like, when you do the math, the mass savings are immense, right? So what our goal is really is to have like the most lightweight reentry system out there, like in the world, period. And that opens like completely new potential applications, right? So when we look at our roadmap, Phoenix 2 is just what we do within the next 1-2 years. We already have a larger Phoenix 3 vehicle on the roadmap. And then after that, what we're looking at is the reuse of rocket upper stages. And they were talking, vehicles that might have something like 5 tons of empty mass that we want to be able to bring back from low Earth orbit. And on upper stages, well, every kilogram counts, right? Like every kilogram that you need for your thermal protection system, for your reentry system, is 1 kilogram less of payload. So we have to be extremely lightweight in our construction. And that's what we aim for.
Yeah. So one thing we were asking ourselves in the case of returning stuff is the Starship era, right? Where you actually, where the unit economics will completely change when it's about mass. Now you said this is one of the key advantages. This, of course, is only valid for the bringing stuff back case, not for deploying somewhere, what we talked about before, right? How do you see that? And how does this maybe risk your approach?
Yeah, I mean, Starship is coming for sure, right? Like SpaceX is having massive technical difficulties to get it up and running. They're at flight 10 now, and it's still not reliably returning. But I mean, that only tells you about the magnitude of the challenge, right? Like we're talking about orbital velocities, 8 kilometers per second that you have to reduce pretty much to zero. It's freaking hard to do, but they're going to make it. I'm actually quite sure of that. It's just a question of time and money pretty much until that vehicle flies. And I think it will bring down the cost of launching things to space by another order of magnitude, right? Like another factor of 10 at least. But the question is, are all vehicles then going to follow the SpaceX Starship example? And I personally believe not, because the Starship is a massive vehicle, right? Like we're talking about 150 to 250 tons of payload to low Earth orbit. I mean, can one of you imagine that thing like launching close to European soil? It's hard for me to imagine actually because of, the noise and the risk and everything involved in there. So I think what we're going to see in the future is a mix of different launch vehicles, right? Like we have a mix of vehicles in air traffic or in ground traffic, right? Like not everybody uses a car. Some people use a truck. Not everybody uses a jumbo jet. Some people use like a Cessna, including me, right?
Yeah.
There's going to be a mix of different vehicles. And the type of technology that you see on the Starship is not downscalable, right? So if you are, let's say, ESA Aerospace, Maya Space, RFA, and you say, I would like to have my upper stage back from space, it's not going to work with that Starship technology because you're just going to be too heavy. You will end up with pretty much zero payload fraction. So you need a different technology, which is extremely lightweight. And that's where we come in. Let's say for the small and medium launchers to make those upper stages reusable, that's where we come in.
Yeah. I would have so many more topics here, but we also want to cover some others. So I will park that for another podcast with you on also other discussions. But you mentioned a bit the innovation and the concept, and it needs a lot of great engineering and a great team. And we were asking ourselves what your degree of vertical integration is and how your team structure is. So what do you do in-house? What do you buy? And how can you actually procure existing?
Yeah. So in the long run, the level of ambition that we have here is to pretty much offer this access to space as a service, all included, right? So we want to start really with the customer at, convincing the customer that we are the ones to solve the problem for him, sign the contract, integrate the payload, launch it to space, operate it in space, bring it back down, hand it back over to the customer, do the refurbishment of our own vehicles, and do all of the developments pretty much in-house. But in the short run, you always have to ask yourself as a startup, like, which resources do I really have and what can I do in-house? And we really focus on those aspects that cannot be outsourced. So we build our own heat shields, we build their own main structure, we build those electronic components that we cannot procure, like the PCBs connecting all of our sensors and actuators. We program the software that we cannot procure, like, for example, the guidance, navigation, and control algorithms that you need for a deorbit burn to bring you back from space, or for atmospheric flight, because there is no company out there that is doing it, especially not in Europe. And everything else, like when it comes to, let's say, a space-grade onboard computer, sensors, right, like magnetometers, sun sensors, star trackers, reaction control wheels, and so on, we procure those from partner companies. And what we then do is of course the design, but in the end also the assembly, integration, and testing.
Yeah.
And for, let's say, the customer handling, we also work with partners. So, for example, one of our biggest partners that we have is a company called SCU, Space Cargo Unlimited, a French company that has roughly 10 years of experience of handling customer payloads, for example, on the International Space Station, but also in other missions with other vehicles. And so the way that we share the work here is that they do a lot of the outreach, the sales, and combining those payloads. And we are in the end, let's say, the container operator, right? Like we put all of those combined payloads into our, which we call the Phoenix, and we launch it to space and operate it and bring it back down. Yeah.
And you are already more than 50 employees, right? So based on my LinkedIn research, like a growth in the past 2 years of more than 200.
Yeah.
What I can say is when I looked into the team, it sounds like a really badass engineering team, like a lot of space engineers, electronics. There's even an architect and so on. So not a software architect, like a real architect. So really, really exciting.
Yeah, it's so we are pretty much structured currently into 7 teams, right? So we have one business and operations team that handles everything from business development, payload management, to finance, human resources, logistics, mission control, and communication also. But then we also have like 6, as you said, hardcore technical teams, right? So we have a systems engineering team that is responsible for the first drafts and for putting out the requirements and making sure that the interfaces are properly handled, but then also eventually for the integration and testing, making sure that the vehicle has been designed to their specifications and is also built like that. And then we have a structures team, a workshop team, an electronics team, guidance, navigation, control, and a software team. So I think from the team structure, you already see where this is going, right? Like we really want to be able to offer the service completely end to end. And of course, at a company size of a bit more than 50, now approaching 60 employees, that means that every team is maybe on the order of like, 7, 8 people. Some are a little bit smaller, some are a little bit bigger. It's not going to get boring here, right? Like when you work as an engineer for Atmos, it's, I have to say it in a careful way, but it's like work and no life balance pretty much.
Work-life blending. This is what I call
pretty
it.
pretty much. For me personally, it's I love what I'm doing, so it doesn't feel like it's too much work. But of course, like this, this won't work with 35-hour week and an easy lifestyle. Like it's hardcore engineering, and we have some super hardworking people here. I'm really proud. Like every time that I go through the workshop and I see how it's progressing, it's pretty.
Having more than 50 people, and you don't have your first mission yet executed.
We have actually. It's been just a few weeks. We flew on the SpaceX Bandwagon 3 mission, and so this was our Phoenix 1 vehicle, very first vehicle, including 4 customer payloads. And we flew that from Cape Canaveral Space Force Station in Florida, circled the Earth 1.5 times, and then re-entered over the South Atlantic. So that was the very first big technology demonstration, and we are very happy that it also went well. So the spacecraft switched on, and we got a whole lot of data. There were also a couple of things that did not go as planned, as always on a first test flight. But I think, inside of Atmos, we're all very, very happy with the outcome of that first flight.
So now the revenue realization starts, right?
Exactly.
But think about that big team, and we know also you are venture backed, right? Can you tell us a bit about the funding background of your company, and how is it to actually raise for such a deep tech space topic?
Yeah, indeed. Venture capital backed. And we have raised a little bit more than 10 million euros in our seed round, all in all combined. So it was over several intermediate steps. And the investors that we have, we are also very lucky that they belong to pretty much the best investors that you can have in Europe, right? So we have investors like Seraphim, global number 1 investor for space companies. We have the German High Tech Founders Fund, state-backed deep tech fund. We have OTB Ventures from the Netherlands and Poland. We have Expansion from France. We have Bal Nord from Poland, and a number of other companies, Amadeus Apex, for example, UK and Austria. So really, really good investors. I think you have to have those investors also, because as we all know, space is very expensive, and it doesn't stop at one funding round. So we are in the middle of fundraising right now also, just about to close our Series A. Luckily, so far, we were able to pull this off with mainly European investors, Seraphim and E2MC, for example, that we also have in our team. They also have American roots, but the majority of our investors so far are European. And given the current geopolitical situation, it is, of course, quite important to take that into consideration, especially if you want to go for dual use and defense contracts. I think in future rounds, like when it comes to, let's say, Series B, Series C, we will also have to look over the ocean, and hopefully the situation will also, normalize again at some point. I think that, America and Europe are natural allies, have always been and will be. And I hope that it will get a little bit more normal again over there. So we'll see how it goes.
And on that subject, right? I mean, you've mentioned you've raised a little bit of money. What I found extremely impressive about that is you didn't raise a lot of money, right? You raised some money and you've been successfully to orbit and back. There are other companies like Vada Space in the US, the exploration company in Europe, where they wanting to go more into the human spaceflight direction. But how do you differentiate yourself from them, and how have you been able to produce such a high degree of efficiency in terms of just getting stuff into orbit and down to the lowest amount possible in terms of venture backing?
Yeah. So I think there's 2 aspects here, right? So first of all, I think if you really want to make a difference in spaceflight, in the end, it comes down to the price per kilogram, right? So in the end, you really need to be more affordable than the other companies out there. And the price per kilogram is, of course, determined by your mass efficiency, and we aim for that. It's determined by the price for the launch. It's determined by your operations cost, but it's also determined by the amount of money that you actually put into the development, right? Like, because if you put like hundreds of millions into the development of your vehicle, well, that means in the end, your vehicle has to make potentially high double digits or even triple digits of millions per flight to actually recover that cost, right? So from the beginning, we said like we have to be more cost efficient also in our development. Now, if you want to be that cost efficient, there's, I think, like two factors of achieving that. Number one is really having a really, really good team. What we have not talked about in the beginning about my background is in the military, I did like 7 years in the conventional armed forces and then also 7 years in special operations. And what we always said there, and what was also you really felt that like based on experience, is that you can achieve amazing things with a small team of really highly motivated and highly trained people that you cannot achieve with a really big team of average people, right? So from the very beginning, we put a very, very high emphasis on hiring really just the best of the best in terms of motivation and its skill sets. Like actually almost all of the 50 first employees were selected directly by me or by Marta, my deputy, to make sure that we really have the best of the best. And then the other part, of course, is also you have to be willing to take risks. So if you develop your spacecraft exclusively, let's say, based on ECSS standards in Europe, and you follow the book of old space, well, then you have a high chance that you will make it at your first try, but that first try might take you years and years, in some cases even decades, right? So when we look at, for example, the development of the Space Rider in Europe, the European Space Agency's Reentry vehicle, it's been in development for 15 years now and still not flying, right?
Yeah.
So you have to be willing to also go fast and break things and take the risk that something might also go wrong on your test flights. But I mean, that's exactly how back in the 60s, Kennedy pretty much put a man on the moon, right?
But maybe just to chime in there, I think the other space companies would say the same thing, right? They would say they have a great engineering team and they would say you need to take risks. That's why we're a startup. But like, what takes you apart from the other companies, maybe also in the approach?
Yeah, but I mean, like, when you look at risk, what does that actually mean? In a lot of cases, it means you go faster, right? Like, and when you look at actually the real numbers, like you compare the real numbers from funding to first flight, you will see the difference between Atmos and other companies. We have been flying extremely fast, right? Like we pretty much stick exactly to the timeline that we had promised to our investors. And we flew with like, I think we flew after 20 months when we had promised 18 months. So it's like almost exactly on time for space standards. And you have to do that, right? Like if you say, I need, 5-6 years to develop my reentry vehicle and I'm going to do like 2 smaller demonstrators on the way. Yeah.
Okay, so
you might make it after 5 years, but you might be out of business by then.
Yeah. So the efficiency is due to good engineering, not only the Swabian frugality, one could say.
Swabian frugality helps for sure. We are based close to Karlsruhe here in Baden-Württemberg, and people are trying to turn every euro around twice. We do that too. That's for sure. But yeah, it's also really hard work and then really also willingness to take risks.
So Daniel and I really have so many questions, but we need to move on to the last chapter of our podcast, which is always the ecosystem, right? And so you have been partnering, you already mentioned a couple of companies you've been partnering, for example, on the payload side of things, but there was one partnership which stood out, at least for Daniel and myself, which was ARX Robotics, right? Which is not a space company. So could you tell us a little bit more about the partnership there?
Yeah, indeed. ARX is not a space company at all. It's a defense company, a drone company, actually. And one of the founders of ARX, their CEO, Mark Wiedfeld, he and I, we get along really well. He's also a former army officer, so same background that I have. And Mark and I, we met and we talked, of course, about the challenges that you have in every startup, like, fundraising, getting the right people, getting the product up and running. But then we also quickly realized that there are some really big synergies between what they do and what we do. So what we do is pretty much we have this reentry vehicle that can put you to any place on Earth, right? So it means it can put anything to any place within very short time. It gives you pretty much unlimited global range. And the problem that drones have, and what ARX is developing is specifically ground-based drones, but also flying drones, is drones have limited range. And when we look at what's happening in Ukraine right now, I think everybody sees that the future of warfare is very much strongly driven by drones, especially when you have on the one side a country like Russia, which is just relentlessly putting more and more people into the battlefield. And on the other side, you have a country like Ukraine, which is much smaller and doesn't have that amount of people. Or you have Western societies where people are actually not willing to put like hundreds and thousands of soldiers onto the battlefield, but where there's a high level of technological advancement and a high amount of money available, pretty much. Right?
Yeah.
That drives the battlefields towards drones. Now, drones, they have limited range. So you already see where this is going, right? Like combine drones with their limited range with our unlimited range, and you are pretty much able to put military goods to any place on Earth with very, very short notice, and also very, very deep behind enemy lines. So
yeah.
And that's how we got together.
Very interesting. Although not on the defense side, but there's a parallel to the founding story of LiveView, because we were thinking about the same thing. The name LiveView came from our view that you have a big opportunity in drone remote sensing, identifying stuff with high fidelity and high accuracy, and satellite, which is like large scale around the globe without any hardware deployment. And so at the very beginning of LiveView, we wanted to combine drones with satellites and build live Earth observation, which is ultimately the same concept here. Funny.
Exactly. Yeah, exactly.
Yeah. Also now in dual use and defense, also a big topic of innovation. And you just mentioned that this again shows the intersection of space and defense, and we see this right now a lot in the news, also specifically in Germany, right? Promise of a lot of budget going into that field. Do you feel that acceleration already, or is it just in the news?
Yes, I think you can feel it quite well. I mean, I have always loved history, and when you look back in the history of spaceflight, I mean, it's always been super closely connected, right? So the first rockets that we had were actually ballistic missiles. They were just converted to carry astronauts or satellites. The first communication satellites were military satellites. The first Earth observation satellites were spy satellites, pretty much. And then when you think about navigation today that we use for our Google Maps, I mean, those GPS satellites were invented by the Americans to guide their bombs and missiles, right? So that connection has always been there. It's just that in Europe and specifically in Germany, we have allowed ourselves to look over that, and we are paying the bill for it right now, right? Like we are lacking the military surveillance and reconnaissance satellites. Like you see that very clearly in Ukraine, that Ukraine is dependent on target data that comes from American satellites. We are lacking the communication capability, right? So if Elon were to switch off Starlink in Ukraine tomorrow, it would be a serious problem, right? And yes, navigation is more or less solved with the Galileo constellation in Europe right now, but that's only a starting point, right? I don't even want to talk about really like the actual strike capability, right? Like, because having the information and being able to communicate, that's one side of the story. You also need to be in a position where you can credibly deter an enemy like Russia from attacking you by saying that, listen, if you do that, we also have the capability to strike your airfields, your military factories, your refineries deep behind the enemy lines. And we're lacking all of that in Europe and specifically in Germany. And there's a lot of movement right now. And we feel that also in direct exchanges with the Bundeswehr, for example. I think it would still have to go much faster given the timelines that everybody is considering for a potential escalation. But it is what it is, right? Like we on our side, we are pushing as fast as we can to support that.
It is what it is, but it also shows like the similarity, right? You can use Earth observation to prevent wildfires. You can use Earth observation for targeting. You can use your technology to put emergency goods into an area which was affected by an earthquake. You can put military goods and weapons into an enemy contested airspace potentially, right? It is with the space industry. It's the origin of the space industry, right? And I think what I see right now is also that this perception and the dialogue and the ethical assessment is changing in the industry a bit, right? And everyone is thinking about this. How do they position themselves? So
absolutely,
coming from that defense topic, maybe looking a bit more into the bright space future, the next decades. So you are building something very, very unique and innovative. But there has to be some infrastructure in place that your use case, your approach is really thriving. We talked about space stations. We talked about Starship bringing things up. So do you have any key assumptions where you are totally convinced that actually this will happen in the 10 years, which enable your business case and your company, which most of the people still miss?
I think we will see two things happening. number one, we will definitely see fully reusable launch vehicles. And that's going to be a massive changer for the economics and also for the recurring rate of access to space. We were very used to it being normal that there's only like 10 launches per year in Europe. I think what we're going to see within 10 years is that it's normal that there's like 1,000 launches to space per year. It's going to be on a daily basis pretty much, right? You can choose actually several launches on a daily basis then to go to space and also back again. So it will be completely normal that you can just go up and go back. So I think that's what we're going to see for sure. The militarization trend, yes, it will happen, right, for sure. But let's maybe look more on the positive side. I think what we're also going to see is industry in space. Right now, there's only like three things really that make money in space. It's satellite communication, it's observation, and it's navigation, right? I think the fourth thing that we're going to see that's really going to make money in space is going to be in space manufactured goods for the use of people on Earth, right? Could be in biomedicine, could be in semiconductors, could be in glass fiber or quantum materials. But I'm actually 100% sure that within those 10 years, we will see that. We'll see some goods that can only be manufactured in space for the benefit of people on Earth.
And the last question,
really exciting for me, yeah.
Yeah, and the last question from my side, which I was asking myself, was when you think about this future, there has to be a logistics hub in space, right? Like so big place to store stuff, right? And do you plan to build this also on your own, or do you see this going to happen and be solved by others?
I mean, I would love to say, yeah, we do it all ourselves, but no, I think it's too big for us alone, right? Like this is going to be a more collaborative effort. I mean, when you look at the complexity of the International Space Station, like how many nations have been working on that, 100 billion spent, it's massive, right? Like it's one thing to put up a single spacecraft that can return. It's a completely different one to actually have several building blocks that can, dock in space, do proximity operations, produce power, get rid of the heat, store things, have robotics on board. The complexity is enormous, right? So I think that would be a little bit too big for us. Something that I could think of that we might also participate in is another different, actually quite exciting topic that I also think we're going to see in the next 10 years is going to be data centers in space. And I think there's like two use cases for data centers in space. One, I think very well, right? Like for Earth observation, there's a lot of data that is created in space, which is actually not useful to send down, right? So when you take pictures and you have cloud coverage on it, what are you going to do? You're going to use your downlink capacity, or are you going to just calculate that out and send down only the valid data where there's no cloud coverage, for example. So I think there's going to be way more computing in space for space applications like Earth observation. But I think what we're also going to see is that some of the computing that we do on Earth right now, especially for artificial intelligence, it's also going to move up to space. Because, you have pretty much unlimited amounts of solar power up there. You have unlimited amounts of space to put up your radiators and to actually put up your server racks. So I think it's just a question of economics. And, 10 years ago, it would have been impossible. But 10 years into the future, when we see another like 10-fold or maybe 100-fold reduction in launch prices, you're going to see data centers in space.
Yeah. So, very, very interesting to hear your perspective on that. But I can say I 100% share your opinion around the production of materials in orbit, because when we started Live Your prior to that, we had this event series called New Space Vision, and back then I also put up a couple of hypotheses about the space industry, and it was exactly that we would move from no weight, which is data, to what provides the biggest value for the least amount of kilograms, which is like high value assets, which can only be produced in orbit. So very excited to see what these materials might be in the future. You've mentioned what are other opportunities you see in the space industry. And I have to say I'm a big Atmos fan now. But what are other hidden champions, other companies in the space industry where you say they are great? Obviously beyond maybe SpaceX, which we all know.
More like the hidden champions.
Yeah, hidden champions. That's a good question, right? Like, if you ask me for something like on the scale of SpaceX, one company that I'm really excited about from the big ones is Stoke Space in the US. But when you ask me for hidden champions, like in this area, for example, one company that I would totally recommend is ISP Tech. We work with them for our propulsion system to bring us back from space. Lucas and Felix and their team, they're amazing. So they both got their PhDs at the DLR in Lampolshausen on testing rocket engines, and they do green propulsion. It's very high performing, very scalable. It's a really cool technology. So
Yeah.
very, very highly recommend that hidden champion.
And you already answered our question who we should bring onto the next episode, which is great. And which also brings us to the end of this this conversation, which I very much enjoyed. So thanks a lot, Sebastian. I think this was extremely interesting and very impressive what Atmos is doing. Science fiction becomes science reality for sure. So thanks a lot.
Thank you both for having me.
Yeah. And also thanks to all the listeners to obviously tuning in again. Please make sure to provide feedback on the podcast platform you're listening this, and make sure to tune in also next time when we have another fascinating guest on the New Space Vision podcast from the new space industry. So thanks a lot for tuning in.